Hello, sir. Hello. Please, somebody reply if I'm audible or not. Hello, everyone. Welcome to School Quiz. My name is Jitendra Srivastava. Today is another live session for the class 10th mathematics, and our topic is quadratic equation. So let's start. Today, I want to tell you some formulas of Sridharacharya, which is known as Sridharacharya's rule, and we will do some exercise on that, and we will move forward. So let's start. First of all, I will derive the formula of Sridharacharya. Is it visible? So the formula is known as Sridharacharya. Sridharacharya's rule. It is known as. So now we will start doing this. So consider, first of all, what we will do, we will have to consider a quadratic equation that I have told you, the standard form of quadratic equation, which is ax square plus bx plus c equals to 0, where a, b, c are real numbers and a cannot be equals to 0. So that is the condition. So I will write here and a is not equals to 0. So this is the condition. So I will derive the formula of Sridharacharya rule from with this equation only. Let's see. First of all, what I will do, we will bring this plus c to this side of the equals, so it will become minus c. Okay. Now, what we will do, we will have to divide this equation with the coefficient of x square. So here the coefficient of x square is a. I hope it is visible to you all. If not, then I will move my screen to this. So we have to divide this coefficient of x square with coefficient of x square. So both the side we have to divide. What we will write? We will write here dividing throughout by a. So we have to divide the equation both the sides with a. What we will get? Let's see here. A. We will divide a by a. x square upon a and plus bx upon a equals to minus c upon a. So what is remaining here? This a will cancel this a. So what we will get? We will get x square plus bx upon a equals to minus c upon a. If I would have to write, I would have written this directly. For you all to understand, to make you understand, I have written this equation also, this line also. You can skip to this also directly. Write this one and write this. Okay. Now moving on to the next step. What we have to do in the next step? In the next step, we have to add both the sides some numbers, some digits. What is that? I'm writing here. See here. Adding b upon 2a whole square both the side. We have to add this number both the side. So what we will get by adding it both the side? What we will get? We will get x square plus bx upon a plus b upon 2a whole square equals minus c upon a plus b upon 2a whole square. This will be the equation by adding this to both the sides. In this equation, we have added b upon 2a whole square. So it will become like this. Why we are adding? We have to make a formula here, a plus b whole square. That's why we are adding this. We are doing this kind of things. We have to make this step. So now, after adding this, what we will get? I am erasing this, rubbing this upper one section. Now, x square plus bx upon a plus b upon 2a whole square equals minus c by a plus b upon 2a whole square. If it is not visible, then I will write it more down. Minus c upon a plus b square upon, sorry, not b. I will not open right now. B upon 2a whole square. I hope it is visible now to you. Now, what we will do? We will see here what we are getting. It is somewhat like formula of a plus b whole square. See here, it is a square, it is b square, it is 2ab. How? In 2ab we will get 2 into the b will be b upon 2a and a will be x. So we will cut this, so it becomes b upon a x. This line is coming. So we can see it is following or the rule of the formula of a plus b whole square. So we have to do that only. So by that formula, we can write here x plus b by 2a whole square. When you will open this, you will get this only. Okay, it is the shortest form of this. Now, what we do? We will open this. Open this square bracket. It will become minus c by a plus b square upon 4a square. Okay. I hope you have understand this. Now, what we will do? We will take calcium here. We don't touch this one. We will take calcium here. It will be written as it is. Now we have to focus on this other side of the equal. Now, first of all, I hope you all have remembered the rule of adding fractions. So what is the rule of adding fractions? First of all, we have to make their denominator equal, or we have to make it equivalent. So here the denominators are not same. So what we will do, we will take LCM. So, but taking LCM was easy in previous classes. Like we have to take only the numbers. But here algebraic expressions are also given. So how to take polynomials, LCM of polynomials. See here, what will be the LCM of A? It will be A only. We have to factorize it first of all. So the factor of A will be A only. And factor of 4A square will be 2 into 2 into A into A. Okay. And we have to take common. What is common in this? In both the numbers, what is common? A is common. So we will take A. And what is the remaining rest? We will multiply with this number only. So the remainings are 2 into 2 into A. So it will be 4A. So we will multiply A into 4A. It will become 4A square. So our LCM will be nothing but 4A square, this number. So I have given you the steps how to find a LCM of any polynomial. So this is the method by which you can find the LCM. I hope you have understand this. So now I'm moving forward. Our LCM is 4A square. Now what we do next, we have to divide this 4A square by A. So when you divide 4A square by A, what you get? You get 4A. So what we will do, we will multiply 4A with minus C. What we will get? We will get minus 4AC. Now we have to divide this 4A square by this 4A square. So what we will get? We will get 1. Now we will multiply 1 with B square, we will get B square only. So it will be plus B square. I hope you all have understood up to this part. Now moving on to the next step, what we have to do. We will, the square here will go that side, it will become under root on this whole equation. Okay. So it will be like this. And I am switching this number, their positions, like we can switch between this and subtract. We will write first B square and we can write this later on, minus 4AC. Now upon 4A square, you can write like this also. The square, when goes that side of the equals, it will put under root on the other equation. So now, what we can see here, we cannot take square root of this, but we can find the square root of this number. So, what will be the square root of this number? The square root will be 2A. So, what we will write? Under root B square minus 4AC upon 2A. But we have to write plus and minus also here, because whenever we open any under root, it will either be in positive number or in negative number. So we have to write both the numbers, plus minus 2A. Now what we will do next? And here, when B square minus 4AC is greater than, I think you are not, it is not visible to you all, greater than or equal to 0, then only it will follow the rule. B square minus 4AC is greater than or equal to 0, then only this rule will be followed. Okay. Now, we will bring this B upon 2A to that side of the equals. So it will look like something like this. X equals to minus B upon 2A. This plus will become minus here. Minus B upon 2A and plus minus under root B square minus 4AC upon 2A. Now, what we will do? Now you can see here, in these fractions, in both the fractions, the denominator are equal. So we can add or subtract the upper numerators without taking any LCM. So our LCM will be 2a only. So I am writing here x equals to 2a and minus b plus or minus b square minus 4ac. So this is the formula of Sridharacharya. I hope it is visible to you all properly. The formula is x equals to minus b plus minus b square minus 4ac upon 2a. These 2a and 2a are added, sorry, taken as a LCM because both are same. So upper numerator will be added without changing any in the value. Now you can write under the box, it is all the Sridharacharya rule or formula. Now what we'll do, plus ax square plus bx plus c equals to 0 has two roots. Every quadratic equation has two roots. We have known this has two roots. So what we can write here, alpha and beta. We are taking the two roots alpha and beta. And for alpha and beta, how do we find that? The formula is, it can be finded or given by the alpha will be, how we will find the alpha? The formula is minus b plus, not minus here, only plus b square minus 4ac under root and upon 2a. And how we will find the beta? Beta will be minus b minus, not plus here, it will be minus only. So the plus and minus are are divided among alpha and beta. Okay. So it will be b square minus 4ac upon 2a. I hope you all understand this, what I am writing here. If do you have any doubts, you can ask. No doubts. So I'm moving forward. So in the equations, there is some more point in quadratic equation that is known as discriminant or capital D, written as capital D. The value of capital D is always b square minus 4ac. So it is known as discriminant. Okay, for the equation ax square plus bx plus c equals to 0, we can say the expression b equals to b square minus 4ac is called the discriminant. It is known as the discriminant. So now there is an important note. Please note down that ax square plus bx plus c equals to 0 and their roots will be real when the b square minus 4ac is greater than or equals to 0, then only the root of this equation will be real numbers in real. Okay, so the roots of this equation will be real when the value of discriminant, or you can say b square minus 4ac is always greater than or equals to 0. Whenever the value will be either greater than or equal to 0, it will be real. The roots are called as real. So now that formula, in place of b square minus 4ac, where it is written the alpha, and for alpha and beta, you can write b. So the formula will be something like this: alpha equals to minus b plus under root d upon 2a, and for beta it will be minus d minus under root d upon 2a. In place of d square minus 4ac, we have written d, capital D. It is known as discriminant. Okay. So there are some cases or nature of roots. How to find the nature of roots? We have to know the nature of the roots, like if it is real or imaginary or equal or distinct. So how we will find that? There are some conditions. 3 cases are there. So we will focus on this one. Now I am moving on to that part. Nature of roots of quadratic equation. So the first case first. What is case first? What it says, if d is greater than 0, if the d is greater than 0, d means b square minus 4ac, always remember that, discriminant. Okay, so in this case the roots will be always real and unequal. The both roots are not equal in this case. Okay, both the roots will not be equal. Every quadratic equation has 2 roots, always remember that. And in this case I can write, in this case roots of the equation will be, roots are real and distinct. Distinct. So distinct means unequal, not equal. Okay, or you can write here unequal. They both cannot be the same. Unequal or distinct can be written here. Okay. So these roots are given by, there is some formula for it. These roots can be finded out by alpha equals to minus b plus under root d upon 2a, and beta will be minus b minus under root d upon 2a. For this case, if d is greater than 0, the value of d square minus 4ac is greater than 0, then only we have to apply this rule to find out the roots of the equation. And you will find that the roots which we are getting are always real number and are in unequal. Both the roots will not be equal, not be same. Okay. Now case 2. What is case 2? Case 2 is if d is equals to 0. What if d is equals to 0? Means the value of discriminant or b square minus 4ac is equals to 0. So in this case, roots will be real and equal. In previous case, the roots were real but not equal. But in this case, you will find the roots are real and equal also. When the value of d becomes 0, equals to 0, then the roots will be real and equal. And if the both root are equal, so we will have to find with the same formula only. And the formula for root will be, the formula will be minus b upon 2a for both the roots, either for alpha or beta. We have to apply this rule only. When the value of d becomes 0, then we have to apply this rule. Okay, not the whole rule minus b plus under root d upon 2a. We will not apply that rule here. We will apply minus b upon 2a for both the roots, either for alpha or for beta. Okay, now moving on to the next case. If the value of d is less than 0, if the value of d becomes less than 0, whenever we find any value b square minus 4ac and it comes in minus number, minus less than 0 will be always minus integers. So what we can say here, the roots will be imaginary. What it will be? Imaginary means unreal. And we can say that the given equation has no real roots. So there is no formula to find out the roots of this equation. If you find the value of b square minus 4ac in negative numbers less than 0, then less than 0 will be negative numbers always. It will be always negative number. So we can say the roots will be unreal or imaginary. In this case, I'm writing this. Roots are imaginary. Imaginary means not real. The roots will be not real. Okay. And we can say it has no real roots. So if no real roots, then there will be no formula to find out the alpha or beta. I hope you understand these cases, and we can make a chart also for this. How we will make a chart? First of all, cases. Right here case, and here nature and formula. So in case 1, if d is greater than 0, if d is greater than 0, then roots will be real and unequal. And the formula I have told you, it will be minus b minus plus b or minus b upon 2a. I have written both the formula together, and for alpha it will be in plus, and for my beta you have to write minus. Okay, I have written both in this same formula only, but don't get confused. And case 2, if d equals to 0, then roots will be real but equal also. Real and equal. Roots will be real and equal. And the formula will be for both the roots only one formula, minus b upon 2a. And case 3, if b is less than 0. If d is less than 0, then the roots will be imaginary. What will be? Imaginary. And there will be no real roots. No real roots, so no formula for it. Okay. I hope you all have understand this session. Uh, if you have any doubt, you can ask here. I am here only. Shall we move on to the next question section? Now we will do some questions. The first question is, show that the equation 9x squared plus 7x plus 2, sorry, minus 2 equals to 0 has real roots. What we have to show? It has real roots and solve it. The question is, and solve it. How we will solve it? First of all, we have to show that this equation has real roots. So how we will solve? See here. Compare it. The equation is 9x squared plus 7x minus 2 equals to 0. What we will do? We will now find the value of a, b and c here by comparing it with the standard form of quadratic equation. So what was that standard form? The standard form was ax squared plus bx plus c equals to 0. So now comparing this with this equation, we will get the value of a, b and c. So what we can say, comparing it, on comparing it, we get a equals to 9, b equals to 7 and c equals to minus 2. We are getting three numbers, 9, 7 and minus 2. Now what we will do next? We will have to find the roots by the formula only. So first of all, we have to find the discriminant. That is, the formula is b square minus 4ac. So how we will find b equals to b square minus 4ac. Check what we are getting. We have to check. So now we have to put the values of here only. The value of b is 7. So we will put here 7. It will become 7 square minus 4 into a is 9 and c is minus 2. So 9 minus 2. Now what we will do? We will multiply it. It will become 49 minus 4 9 is 36, 2 is 72. Or 9 2 is 18, 18 4 is 72. And this minus, sorry, this minus and this minus will make it plus. Okay, 72. So now what we will do? We will add this number. So on adding these numbers, what we get? 9 plus 2, 11. 7 plus 4, 11 plus 1, 12. So what we are getting, the value of d, it is 121. So what we are getting? 121. So as you can see, the value of d is greater than 0. So we can say the roots will be real. What we can say? The roots will be real. So it has been proven that the value of roots will be real. How we can write? We can write, since d it is d equals to 0 here, or you can say it is greater than 0. So we can say this value has real root. Now how we will solve this? Now I am writing here the value of t is 121 and it is real. The roots will be real. So now under root t equals to 11. What it will be? You can write 121 under root and you will get 11. So value of d is 11 here. Okay, under root d. Now what we will do? We will put it in the formula alpha equals to minus b plus under root d upon 2a and beta equals to minus b minus under root d upon 2a. So by using these formulas, we will find the value of roots. Let's see what we are getting here. minus, and the value of b was 7. So minus 7 plus 11. The under root b is 11. Value of under root b is 11. So we will directly put 11 here upon 2 into 9. The value of a was 9. Now in this equation, minus 7 minus 11 upon 2 into 9. So what we are getting here, it will be 11 minus 7, it will be 4 upon 18. Or here will be minus 18 upon 18. So what we can see, we are getting the value of alpha will be 4 upon 18, or you can reduce it, you will get 2 upon 9. And the value of beta will be minus 1. Dividing this, we will get minus 1. Okay. So now the required roots will be 2 upon 9 and 1. This is the root. Okay. So now we will do some next question, other questions also. Hope you have understand this one. It is the same like the previous one. We have to show it has real roots and we have to find the root. So how we will show? We have to compare it. Compare with ax square plus bx plus c equals to 0. Or you can write here on comparing with ax square plus bx plus c equals to 0, we get what we get? A equals to 2, b equals to 5 under root t, and c equals to 6. And now what we will do, we will find have to find out the value of discriminant or d. It will be minus, not minus, b square minus 4ac. So now what we will do, we will put the values of a, b and c here in this equation. What we will get? 5 under root 3 whole square minus 4 into 2 into 6. Now solve this. It will be 5 5 is 25 and the roots will be removed. So the value will be 3 only. Under root 3 multiplied by under root 3, it will become 3 only. Under root will be removed. Okay. So we will write 25 into hello. Sorry for the interruptions. So we are continuing now. So we can say the value of d is greater than 0. So it is proved now that this equation has real roots. So now we have to find the roots. What are the roots? Now the value of d is 27. So under root d will be under root 27. Okay. Or we will open it, then it will become 3 under root 3. 3 3s are 9, 3s are 27. Okay. How we have done this? You can also say by doing 3 into 3 into 3 under root. We can see one pair can be taken out as single one. So one pair has been taken out. So it becomes 3 here, and this under root 3 remains here only. So it becomes 3 under root 3. Now the alpha will be minus b plus under root d upon 2a. So now we have to put the value of b and a. So what was the values of b and a? Value of b was 5 under root 3 and minus 5 under root 3 plus 3 root 3 upon 2a, and a was 2 only. A was 2. So what we will get? We can see we can plus or minus here because both has same under root 3 here only. So by adding or subtracting this, we will get minus 2 root 3 upon 4. Or what we can do, we can cut this, we will get 1 upon 2. So we can say it will be under root 3 upon 2 minus under root 3 upon 2. So now for the value of beta, what we will get? Value of beta, we will get minus b minus root d upon 2a. We will get minus 5 by root 3, 5 root 3 minus 3 root 3 upon 2 to the 4. Now here also we have to add this. We will get 8 root 3 minus will be there only on 2, and if we will cut this, we will get 2 here. So the value of beta will be minus 2 root 3. Value of beta will be minus 2 root 3 and value of alpha will be minus root 3 by 2. And I have to write here also, you can say alpha will be minus root 3 upon 2 and beta will be minus 2 under root 3. Okay. I hope you have understand this session. Now we will do some questions on nature of roots. Okay, there is a question. Find the nature of the roots 4x square minus 5x plus 3 equals to 0. Now we have to find the nature of the roots of this equation. So first of all, what we will do? We will have to find the discriminant. And for that, we have to compare it with the standard form of quadratic equation. The standard form of quadratic equation was ax square plus bx plus c equals to 0. So by comparing that, we will get value of a will be 4, value of b will be minus 5, and value of c will be 3. Okay. Now we have to find the value of discriminant here. The discriminant can be find it out by b square minus 4ac. Okay. Now the value of b will be minus 5 square minus 4 into 4 into 3. Okay, 4 into 4 into 3. Now what we will do? We will open it. We will get 25 minus 4 4 the 16, 16 3 the 48. Okay. So now what we are getting, the value of D is minus 23, which is less than 0. Which is less than 0. We can clearly see here minus 23 is less than 0. Now, so we can say it is less than 0. So the less than 0 condition was it has no real root. It will be in imaginary numbers. The value will be, the roots of the value will be in imaginary numbers. No real roots. No real roots. Okay. The equation has no real roots. Now it was the nature of the equation. You don't have to solve it to the finding out the roots. You just have to find out the value of D and compare it with 0, whether if it is greater than, equal to, or less than. On the basis of that, you can simply say if the roots are real or not, or imaginary or unequal, whatever it is. Okay. So now we will do another question here. Now, in this question, same method we have to apply. We have to show that it has real roots and find the roots. Now, we will compare it with standard form of quadratic equation, which is ax square plus bx plus c equals to 0. So, on comparing it with the standard form of quadratic equation, we will get the value of a will be 2, value of b will be minus 6, and value of c will be 3. Now, what we will do next? We have to find out the discriminant by using b square minus 4ac. Discriminant will be b square minus 4ac. So, the value of b is minus 6. Put that minus 6 here. Minus 4 into 2 into 3. So, what are the values? 36 minus 4 2 is 8 3 is 8 3 is 24. Now, we will minus it. Subtracting it, we are getting 12. So we can see that 12, the value of D 12 is greater than 0. So we can say it has real roots. Now it has been proved that it has real roots because the value of D is greater than 0. Now what we will find out? We will find out the roots of this question. How we will find out? Alpha and beta, or you can say x. Here x is written, so we will write x only. Okay. Minus b plus minus d upon 2a. With this formula, we will find out the roots. So the value of d was 12. So under root d will be 2 root 3. Okay. So we will use this only 2 root 3 here. What we will use? We will use 2 root 3 in place of under root d. Now value of d was minus 6. So minus 6 will be written like this: minus and minus 6 plus minus and 2 root 3, okay, upon 2 into 2. It will be 6 plus minus 2 root 3 upon 4, okay. Okay, now we will take common from here. Common will be 2. So it will be 3 plus minus root 3 upon 4. Now we will divide this. We are getting 2 here. So the value of x will be 3 plus minus under root 3 upon 2. Okay. Either in plus or in minus. You can write here. Where should I write? Okay, I'm writing here only. It will be 3 plus under root 3 upon 2 or 3 minus under root 3 upon 2. These two values will be there for x. I hope you have understand this, and now we will do our next class soon. Thank you for watching this, and do subscribe to our channel School Quiz. The spelling of School Quiz is, I'm writing here, this double Z in School Quiz. Do subscribe to this channel and watch all the related subject videos, and you can find here chemistry or all the subjects, SST, chemistry, science, all the subjects of science and all the subjects of SST and maths here also, English, Hindi, whatever you want to study, you can find it, and it is free of cost. Yeah, you don't have to pay anything. Okay. Thank you for today's class.